Wi-Fi Protected Setup, WPS. Originally, Wi-Fi Simple Config is a network security standard to create a secure wireless home network. Created by the Wi-Fi Alliance and introduced in 2006. The goal of the protocol is to allow home users who know little of wireless security and may be intimidated by the available security options to set up Wi-Fi protected access, as well as making it easy to add new devices to an existing network without entering long passphrases. Prior to the standard, several competing solutions were developed by different vendors to address the same need. A major security flaw was revealed in December 2011 that affects wireless routers with the WPS PIN feature, which most recent models have enabled by default. The flaw allows a remote attacker to recover the WPS PIN in a few hours with a brute force attack. And, with the WPS PIN, the network's WPA2 pre-shared key, users have been urged to turn off the WPS PIN feature. Although this may not be possible on some router modes, the standard emphasizes usability and security, and allows 4 modes in a home network for adding a new device to the network. PIN method, in which a PIN has to be read from either a stick or a display on the new wireless device. This PIN must then be entered at the representative of the network, usually the network's access point. Alt access point may be entered into the new device. This method is the mandatory baseline mode and everything must support it. The Wi-Fi Direct specification supersedes this requirement by stating that all devices with a keypad or display must support the PIN method. Push button method, in which the user has to push a button, either an actual or virtual one, on both the access point and the new wireless client device. On most devices, this discovery mode turns itself off as soon as a connection is established or after a delay, typically 2 minutes or less, whichever comes first, thereby minimizing its vulnerability. Support of this mode is mandatory for access points and optional for connecting devices. The Wi-Fi Direct specification supersedes this requirement by stating that all devices must support the push-button method. Near-field communication method, in which the user has to bring the new client close to the access point to allow a near-field communication between the devices. NFC forum-compliant RFID tags can also be used. Support of this mode is optional. USB method, in which the user uses a USB flash drive to transfer data between the new client device and the network's access point. Support of this mode is optional, but deprecated. The last 2 modes are usually referred to as out-of-band methods as there is a transfer of information by a channel other than the Wi-Fi channel itself. Only the first 2 modes are currently covered by the WPS certification. The USB method has been deprecated and is not part of the Alliance's certification testing. Some wireless access points have a dual-function WPS button, and holding this button down for a shorter or longer time may have other functions, such as factory reset or toggling Wi-Fi. Some manufacturers, such as Netgear, use a different logo and/or name for Wi-Fi protected setup. The Wi-Fi Alliance recommends the use of the Wi-Fi protected setup identifier mark on the hardware button for this function. Technical architecture. The WPS protocol defines 3 types of devices in a network. Registrar, a device with the authority to issue and revoke access to a network. It may be integrated into a wireless access point, app, or provided as a separate device. Enrollee, a client device seeking to join a wireless network. App, an access point functioning as a proxy between a registrar and an enrollee. The WPS standard defines three basic scenarios that involve components listed above. App with integrated registrar capabilities configures an enrollee station. In this case, the session will run on the wireless medium as a series of EAP request-response messages, ending with the app disassociating from the star and waiting for the star to reconnect with its new configuration, handed to it by the app just before. Registrar star configures the app as an enrollee. This case is subdivided in two aspects. First, the session could occur on either a wired or wireless medium. And second, the app could already be configured by the time the registrar found it. In the case of a wired connection between the devices, the protocol runs over Universal Plug-and-Play (UPnP), and both devices will have to support UPnP for that purpose. When running over UPnP, a shortened version of the protocol is run. Only two messages, as no authentication is required other than that of the joined wired medium. In the case of a wireless medium, the session of the protocol is very similar to the internal registrar scenario, but with opposite roles. As to the configuration state of the app, the registrar is expected to ask the user whether to reconfigure the app or keep its current settings, and can decide to reconfigure it even if the app describes itself as configured. Multiple registrars should have the ability to connect to the app. UPnP is intended to apply only to a wired medium, while actually it applies to any interface to which an IP connection can be set up. Thus, having manually set up a wireless connection, the UPnP can be used over it in the same manner as with the wired connection. Registrar star configures enrollee star. In this case, the app stands in the middle and acts as an authenticator, meaning it only proxies the relevant messages from side to side. Protocol. The WPS protocol consists of a series of EAP message exchanges that are triggered by a user action, relying on an exchange of descriptive information that should precede that user's action. The descriptive information is transferred through a new information element, i.e., that is added to the beacon, probe response, and optionally to the probe request and association request-response messages, other than purely informative type length values. Those IEs will also hold the possible and the currently deployed configuration methods of the device. After this communication of the device capabilities from both ends, the user initiates the actual protocol session. The session consists of 8 messages that are followed, in the case of a successful session, by a message to indicate that the protocol is completed. The exact stream of messages may change when configuring different kinds of devices, app or star, or when using different physical media, wired or wireless, band or radio selection. Some devices with dual-band wireless network connectivity do not allow the user to select the 2.4 GHz or 5 GHz band, or even a particular radio or SSID, when using Wi-Fi protected setup, unless the wireless access point has separate WPS button for each band or radio. However, a number of later wireless routers with multiple frequency bands and/or radios allow the establishment of a WPS session for a specific band and/or radio for connection with clients which cannot have the SSID band, e.g. 2.4 GHz, explicitly selected by the user on the client for connection with WPS, e.g. pushing the 5 GHz, where supported. WPS button on the wireless router will force a client device to connect via WPS on only the 5 GHz band after a WPS session has been established by the client device, which cannot explicitly allow the selection of wireless network and/or band for the WPS connection method. Vulnerabilities. Online brute force attack. In December 2011, researcher Stephen Vierbach reported a design and implementation flaw that makes brute force attacks against PIN-based WPS feasible to be performed on WPS-enabled Wi-Fi networks. A successful attack on WPS allows unauthorized parties to gain access to the network, and the only effective workaround is to disable WPS. The vulnerability centers around the acknowledgement messages sent between the registrar and enrollee when attempting to validate a PIN, which is an 8-digit number used to add new WPA enrollees to the network. Since the last digit is a checksum of the previous digits, there are 7 unknown digits in each PIN, yielding 107 equals 10 million possible combinations. When an enrollee attempts to gain access using a PIN, the registrar reports the validity of the first and second halves of the PIN separately. Since the first half of the PIN consists of 4 digits, 10,000 possibilities, and the second half has only 3 active digits, 1,000 possibilities, at most 11,000 guesses are needed before the PIN is recovered. This is a reduction by 3 orders of magnitude from the number of pins that would be required to be tested. As a result, an attack can be completed in under 4 hours. The ease or difficulty of exploiting this flaw is implementation dependent, as Wi-Fi router manufacturers could defend against such attacks by slowing or disabling the WPS feature after several failed PIN validation attempts. A young developer based out of a small town in eastern New Mexico created a tool that exploits this vulnerability to prove that the attack is feasible. The tool was then purchased by Tactical Network Solutions in Maryland for $1.5 million. They state that they have known about the vulnerability since early 2011 and has been using it in some devices. Disabling WPS in the user interface does not result in the feature actually being disabled, and the device remains vulnerable to this attack. Firmware updates have been released for some of these devices allowing WPS to be disabled completely. Vendors could also patch the vulnerability by adding a lockdown period if the Wi-Fi access point detects a brute force attack in progress, which disables the PIN method for long enough to make the attack impractical. Offline brute force attack. In the summer of 2014, Dominique Bongard discovered what he called the pixie dust attack. This attack works only for the default WPS implementation of several wireless chip makers, including Ralink, MediaTek, Realtek and Broadcom. The attack focuses on a lack of randomization when generating the ES1 and ES2 secret nonces. Knowing these 2 nonces, the PIN can be recovered within a couple of minutes. A tool called Pixie Oops has been developed and a new version of Riva has been developed to automate the process. Since both the access point and client, enrollee and registrar, respectively, need to prove they know the PIN to make sure the client is not connecting to a rogue app, the attacker already has 2 hashes that contain each half of the PIN, and all they need is to brute force the actual PIN. The access point sends 2 hashes, E-1 and E-2, to the client, proving that it also knows the PIN. E-1 and E-2 are hashes of ES1, PSK1, PKE, PKR, and ES2, PSK2, PKE, PKR, respectively. The hashing function is HMAC SHA-256 and uses the auth key, that is the key used to hash the data. Physical security issues. All WPS methods are vulnerable to usage by an unauthorized user if the wireless access point is not kept in a secure area. Many wireless access points have security information, if it is factory secured, and the WPS PIN printed on them. This pin is also often found in the configuration menus of the wireless access point. If this pin cannot be changed or disabled, the only remedy is to get a firmware update to enable the pin to be changed, or to replace the wireless access point. It is possible to extract a wireless passphrase with the following methods, using no special tools. A wireless passphrase can be extracted using WPS under Windows Vista and newer versions of Windows. Under administrative privileges by connecting with this method, then bringing up the properties for this wireless network and clicking on Show Characters. A simple exploit in the Intel Pros A wireless client utility can reveal the wireless passphrase when WPS is used. After a simple move of the dialog box which asks if you want to reconfigure this access point. Wi-Fi Protected Setup Knowledge Center at the Wi-Fi Alliance. UPnP Device Architecture. US Cert FU number 723755. Waiting for WPS fix. WPS Pixie Dust Attack. Offline WPS Attack. Hackaloo 2014 Offline Brute Force Attack on WPS.